But let's track the destruction of Rodinia from the beginning in a little more detail on a time-lapse graph so that we can see how it looks like. So here you see all the pieces that we were talking about earlier. We have the pieces that used to belong to Nina right here, which includes pieces which are now pieces of Europe, North America, and Russia. You have the pieces that used to belong to Atlantica, and you also have the pieces that used to belong to Ur. Okay, so now I want to show you a different view of exactly the same thing. This is again exactly the same thing. It's just that I'm focusing on the large ocean that surrounds Rodinia, the large global ocean that you see there. Now you also might notice that Rodinia was not really a large supercontinent with just one big piece of land. It was more like several tectonic plates which are collided together and form one ginormous mesh of plates. But this will eventually crack because of all the pressure of those collisions, and then create new rifts which ended up separating them. And I'm going to focus on the large ocean so you can see the transition that took place, and you're going to notice how the one big thing that happened is that the whole thing will shift towards the bottom here, and so the pieces will go from the tropical area towards the bottom area. And so pay attention as that happens. So we get to the formation of Kenosha by 650 million years. So look at the shift, all right? See how the pieces are shifting towards the bottom, and by 600 million years you already have the Kenosha pretty much formed. Now notice that this piece over here on the top, it's actually very interesting to keep track of it, because this piece is going to end up all the way over here. And I think that's interesting because you can see how much a continent can shift over billions of years because of tectonic plate motion. Okay, the next step, as we know, is going to be the breakup of Kenosha, because the pieces that used to belong to Nina, which are the Baltica, Siberia, Greenland, and Laurentia, are all going to split from it and head towards the poles. And you're going to see that happening over the next few slides. As we enter the Cambrian time, around 550 million years, the pieces of Laurentia, Baltica, and Siberia, and Greenland are all separating from the large big supercontinent we call Gondwana that stays on the southern part. Now these pieces will continue to shift because of the Iaptus Ocean that's actually forming in between them. It will continue to shift because of that crack that actually formed here, and that crack will actually spread over here as well, which is going to end up separating the pieces even more. So fast forward another 50 million years, the pieces are a little more separated. Another 50 million years, they're very, very well separated. Now notice there we have the Orbicae that travel all the way here while this whole thing was happening. I also want to point out that these pieces over here are actually shattering from Gondwana and traveling this way. And that's going to be important as we talk about the formation of Pangea later on. We are now dead on Cambrian time, and the first vertebrates are appearing in the oceans. So life is evolving. Vertebrates, things like the first early fish and things like that, are starting to develop in the oceans. And remember, the atmosphere is still not very oxygen rich, and so it doesn't really allow for life on land. And remember, throughout this whole thing, you have alternating periods of ice age and other things like that. So we're still on Cambrian time. At the end of the Cambrian time, we start the Ordovician. And by now, here you have the Ordovician, and you see that a piece of Gondwana called Avalonia is going to crack and join the pieces from Laurentia, and there they are right there. And also notice that more pieces are going to start cracking from Gondwana because of other rifts forming there, and they're going to be shifting towards the center there as well. Okay. And by the way, this is an example of a large igneous province that formed midway through this whole thing. It's a new piece of land that's forming. Remember, continental formation and creation is still going on, even as the old cratons are moving around. So, fast forward another 30 million years or so, the great occurrence here is that Greenland and Baltica and Avalonia all collide to form one large block over here. And this particular collision is going to form mountain ranges in Europe because it caused the collision. So we have some ancient mountain ranges in Europe that formed because of this particular collision of the Baltic plate with the Greenland and things like that. And this will stay as a unit for a while from now on. By 420, we are definitely already in the Ordovician period, and by now the modern atmosphere starts to evolve with its oxygen rich, which is going to allow the first leaps to land to actually take place. Well, by the time you get to the Silurian period, which is starting about this time, the first land life to appear. Plants will start, like mosses and early ferns, will start conquering the land, and which allows the development of large arthropods to actually go into the land. So we're going to talk about that later. If you fast forward another 100 million years or so, you're going to get to the Devonian period, where the first amphibians are starting to appear on land. You see, between this time and this time, a mass extinction event took place. We don't know exactly what it caused it. Probably a plague or some type of climatic change caused a vast destruction of a large amount of ocean life, Earth. But it also opened room for lots of the new species to take over the land, and the evolution of amphibians will take place because of that. Ferns are starting to take over the land as well. And during the Devonian period, as you can see, that you have the formation of Laurentia in Eurasia almost hitting Gondwana. So the Gondwana makes a big shift towards the center. That's actually what's so characteristic geologically of this period, is that Gondwana will kind of shift towards the center here and almost hit Laurasia and the other pieces that used to belong to Nina. So there you see that it actually shifts. And also you'll notice that some of the pieces which never quite join either of the supercontinents will actually be lagged behind here and make their own shifts. During this period then, the amphibians are starting to take over the land, and you have the formation of an advanced atmosphere. Now, also interesting here is that during this period, coniferous trees will evolve. So before this period, only kind of like ferns were clopping over the earth, and ferns will still be the dominating species for millions and millions of years, but the coniferous species will start to evolve in this place, and because plants now have seeds, they will spread all over the land faster and faster, and will dominate the landscape, allowing more animals, larger animals, to evolve, which takes us to the Carboniferous period. During the Carboniferous period, fast forwarding another 50 million years, you have the formation of Pangea. And notice how interesting that these two pieces, the pieces that used to belong to Nina and the pieces of Gondwana, merged to form the large Pangean supercontinent. So the great formation of Pangea will happen between 350 and 300 million years. And because of this collision, geologically, you're going to have the formation of several mountain ranges in between Laurasia and the northern pieces of Pangea. So you're going to have mountain ranges forming around this area and around this area here, and that's what has the Apennine Mountains and the Northern African mountains are there today because of that collision. And since these are such old mountains, they've pretty much become eroded by now. And the pieces which were on the side and never quite joined the continents or split from them will actually enclose a certain piece of the ocean that we now call the Tethys Ocean or the Tethys Sea. And this actually is separated mostly from the currents of the large super ocean that we call Pantalassa, which surround this entire new supercontinent called Pangea. But Pangea is still forming around here. And the interesting thing that happened with life around this time is the formation of the first reptiles. Towards the end of this period, the first reptiles will start to evolve. And this will happen because of another mass extinction that happened between the Devonian period and the Carboniferous period, allowing more animals or new kinds of animals to replace the ones that were extinct. And so some amphibians were left, but that opened the door for the large reptiles to evolve. So around 300 million years, we start seeing the large reptiles evolve on Earth. Okay? Now remember that as we talked about this, we're tracking the evolution both of life and of the geological events. We are going to do a different video later on the year about the geological eras of time, and we're going to review everything that happened geologically, hydrologically, atmospheric-wise, and everything else. But right now, you should have this picture starting in your mind that the Earth started as a big ball of fire of planetesimals getting together to form a large protoplanet, which then kind of cooled down to form the crust and differentiate into layers. Back when it was still a ball of fire, and then as it cooled down, it allowed the atmosphere to actually rain down and form large oceans. These oceans came from volcanic eruptions and from comet collisions with Earth. That's where all the water came from. At the same time, the atmosphere is forming first from weak gases which get blown by solar winds into the outer planets, then by gases which are outgassing from the volcanoes and forming a layer around the Earth, and then these gases will slowly be changed by the process of life that we just talked about. By the end of the Ordovician period, you have the formation of an oxygen-rich atmosphere which allows the life on Earth to change, and it also changes the climate as it makes the oxygen more common than carbon dioxide, making life on land more possible. And as more and more oxygen gathers in the atmosphere, larger and larger animals are allowed to grow, and that's when you get the large reptiles by the end of the Carboniferous period. And it's called the Carboniferous period because the trees are going to be spreading all over the land. We talked about this at the end of the Devonian period. Coniferous trees are going to be evolving, and this will allow seeds to spread all over the land and create a large landmass full of life. And now, Pangea will continue its development, and if you fast forward another 50 million years, you'll see that the major events that happen is that the Tethys Sea kind of closed up, opening a new area here, where air from Pantalassa can go inside of this big gulf. And you also have the fact that Siberia would crash against the pieces of Baltica and form Laurasia, which will then become the Asiatic and European continent. And this collision is what formed the Ural Mountains millions and millions of years ago, and they're still there separating Europe from Asia. All right? And you also have the separation here of the North American piece from the rest of that, and Greenland right in the middle. Now, what you see here is the final formation of Pangaea, and around 250 million years, the real Pangaea is now formed, because it includes even the pieces of Siberia. And remember, we talked about this. Pangaea's formation is registered by those rock formations that show North America colliding with the African cratons, and also by the collision between Siberia and the Baltica shields, which form the Eurasian plate of today. Now you see that these things are going to be evidence of the formation of Pangaea. But if you fast forward, now we are in the Permian period. The Permian period is when life on Earth was dominated by these ginormous reptiles, and for many millions of years, these reptiles are going to be taking over the land. But towards the very end of the Permian period, which is going to be something close to maybe this time right here that you see in the screen, Pangaea's formation actually causes so much tension in this big crust that's actually colliding that massive volcanoes are going to start exploding all over the place in this large supercontinent. And not only will the eruptions kill a lot of animals, but the world will be covered with ash, and the atmosphere will be blocked from the sunlight entering the earth, and this will result in a massive destruction of producers which no longer have sunlight to create the sugar, and that will kill 96% of ocean life and 70% of all land life, which basically is another one of those mass extinctions. So we had one at the end of the Ordovician and Silurian periods, another one at the end of the Devonian periods, which allowed the reptiles to take over, and now because the large reptiles are dying, smaller reptiles, which were the early dinosaurs, will start taking over the land. So around 250 million years, we enter a new area of the world.